Hi, welcome to Understanding Complex Exponentials, Lecture 2, Quick Review of Important Concepts. In this lecture, we'll review a few basic concepts needed for the rest of the course. So, we'll talk about exponentials, the definition of an angle in radians, the definition of I, and the complex plane. Okay, so let's start with exponentials. If you take a number a to the power of b, so written as a with b in the exponent, you multiply a by itself b times. So a raised to the power of b equals a times a times a, etc., b times. Okay, so multiplying two exponentials, a to the b and a to the c, gives the following. A to the b times a to the c equals a times a times a, etc., a total of b times a times a times a times a, etc., a total of c times. And that equals a times a times a times a, etc., a total of b plus c times, which equals a raised to the power of b plus c. Similarly, a to the b divided by a to the c equals a to the b times a to the minus c, which equals a raised to the power of b minus c. In this course, we will see powers of e, the base of the natural logarithm. Okay, next let's talk about measuring angles in radians. In this course, we'll measure angles in radians, not in degrees. The size of an angle in radians is defined as the arc length divided by the radius of the circle. So, in the picture we show here, for an arc length equal to L, and here the length of the arc is given in green, and a radius R, the angle theta is equal to L divided by R. As the ratio of the circumference of a circle to its radius is 2 pi, there are 2 pi radians in a circle. For reference, here are some conversions between degrees and radians. 180 degrees is equal to pi radians. 90 degrees is equal to pi over 2 radians. And 60 degrees is equal to pi over 3 radians. Okay, next, let's talk about I. So I is defined as the square root of -1. However, we should note that engineers often use the notation j to mean the same thing. J equals the square root of -1. Now we'll give a few relations that we encourage you to check on your own. So I squared and minus I squared both equal -1. I cubed is equal to minus I, and minus I cubed is equal to I. Meanwhile, I to the fourth and minus I to the fourth are both equal to 1. I times minus I equals minus I times I, which equals 1. And lastly, 1 over I equals minus I. Okay, next, writing complex numbers. We can write a complex number z in the form z equals x plus iy, where x and y are both real. Here, x is called the real part of z, and y is called the imaginary part of z. So we can write the real part of z equals x, and the imaginary part of z equals y. Okay, next, the complex plane. We plot a complex number z in a plane with the x-axis as the real part of z and the y-axis as the imaginary part of z. Let's give 4 examples. First, let's look at the red dot. This is at z equals 2 plus 3i. So we can see that it is plotted at x equals 2 and y equals 3. Next, let's look at the blue dot. Z equals minus 4 plus 5i. In this case, the x-coordinate is minus 4 and the y-coordinate is 5. Next, z equals minus 5 minus 2i. This is the brown dot. Here, the x-coordinate is minus 5 and the y-coordinate is minus 2. And lastly, let's look at the green dot. Z equals minus 3i. Here, the x-coordinate is 0 and the y-coordinate is minus 3. We'll make use of the complex plane in the next lecture. Okay, so let's give a summary. In this lecture, we very quickly reviewed a few concepts that will be necessary for this course. So, exponentials, measuring angles in radians, the definition of I, and plotting points in the complex plane. We will be using each of these concepts heavily in the rest of the course. If any of these is unclear, it's a good idea to study it more before moving on to the next lecture.